Have your family or friends ever told you they don't believe in the Bible? It's just a myth. Then give them this book, Our Search for Sodom and Gomorrah, an amazing investigation revealing the evidence for the skeptical mind. This book and DVD documentary gives hard data concerning the story of Genesis from the Bible. A group of skeptics traveled to the Dead Sea in Israel to see what remains of Sodom and Gomorrah. The group was speechless when confronted with the ghostly buildings that resembled fortresses, ziggurats, sphinxes, man-made streams and wells, including tons of ash. As the group continued into the cities, they stumbled upon balls of sulfur brimstone, not in a crystalline form as you would expect, but as compressed powder. Join Simon the author as he consults scientists, geologists, archaeologists, and mineral experts. Now your family and friends can see for themselves the evidence of these incinerated biblical cities. Order now at realdiscoveries.com or call 440-142-473-3684.
Brimstone analysis. Simon Brown, accompanied by a team, went to sites in the Middle East that are now accepted by many to be the cities of the plain, the cities that include Sodom and Gomorrah. He collected sulfur brimstone samples, brought them back to the UK, where they were subject to meticulous scientific analysis. We consult things like mining reports to get geological information. And basically the exercise we're going to try and conduct is find out what the purity of the sulfur samples that Simon collected is. Hello, my name's Roland Johnson Bell, Roly to most people. I'm a reverend, I have a theological degree and a theological diploma. So you'd have thought when Simon Brown came to me a few years ago and said, could I help him do a film on Sodom and Gomorrah, that I would be in the better position to know what the history of this was. However, after I trotted out my conservative evangelical viewpoint, Simon brought me some very amazing new evidence I had never seen before, built on the findings of people like Ron WYATT and Leonard MÖLLER. So I had to set to and absolutely reconstruct my thinking. I was asked to do the script for the film, and I wasn't prepared to do a script for something I couldn't actually put my hand on my heart and say, I believe that. So I did a lot of research, watching the raw footage, doing research for myself to convince myself that this was right. And I have to admit that I'm not the only one probably that's going to be a little embarrassed by the fact that I should be more qualified. Just watch the film and I think you'll enjoy it. Come with us as we go through the brimstone analysis. What the Bible calls brimstone is sulfur. Brimstone is its ancient name. Sulfur is an element. An element is something made of one thing. Basically, it's made of itself. For example, water is not an element. It is made of two things, hydrogen and oxygen, which are two elements. Two molecules of hydrogen and one molecule of oxygen makes water. That's why it's called H2O. Sulfur, however, is an element. It's number 16 on the periodic table of elements. Its chemical symbol is S. There are 118 elements on the periodic table known to man at the moment, and everything that is made of anything in this world, whether it is solid, liquid or gas, is made up of combinations of these elements. The phrase man-made fibre isn't really correct, because anything that man has made and put together is made up of some combination of these elements. Man has never made an element. Laboratory refined sulphur is probably the purest form of sulphur available to man at the moment. The purest raw form of sulphur is often best sourced from underground. It's called flowers of sulphur. It's very crystalline in its composition, and it's about 80% pure. Other places where we can find sulphur is around the mouths of volcanoes. They look a bit like that. They are at best 45% pure, mixed in with lots of other things. Here's a mineralization report, a geological mining report from Steepovac Bay in Alaska. Why are we looking at this? Well, just follow me for a moment. During a mining investigation near Steepovac Bay in Alaska to see if sulphur could be extracted from volcanic deposits, Gilbert R. Eakins had this to say in page 6 of his report. The sulphur-bearing breccia found as float and moraine contained veinlets up to 1/4 quarter of an inch wide and pockets up to 1 inch in diameter. Some of the boulders were from 30 to 40 feet thick. Some specimens were estimated to contain as much as 20% sulphur, but most of the material was thought to contain between 5 and 10%. What are we to understand from our research so far? Why on earth are we looking at a mining report in Alaska, which is nowhere near the Middle East? Well, what we're beginning to find out is sulphur doesn't seem to exist anywhere naturally in a totally pure state. If we look at the bother these guys went to conduct this expedition, the sulphur deposit is 74 miles from a place called Ramsey Bay on a near vertical slope at an elevation of slightly over 3,000 feet. These people were seriously considering the viability of going 3,000 feet up a mountain vertically to see if they could extract sulphur. I would have thought if pure sulphur was available, people like this would have known about that. So here we have the 3 samples that we've looked at so far. We've got laboratory refined sulphur, which as far as we know is the purest, and it's either come from volcanic deposits or from flowers of sulphur. We're going to add into the equation samples from the city of Gomorrah, collected by Simon and the Real Discoveries team. Quick look at these 2 samples. They're roughly the same size, but it's very obvious that the sulphur in them is very different, certainly in its composition. The sulphur in the sample from the city of Gomorrah is very large and very powdery. The sulphur in the volcanic sample is very small and very crystalline, very sugary, or maybe quartz-like in its consistency. Look at the size difference. It's very obvious. So, we're going to take laboratory refined sulphur and we're going to compare it for purity with brimstone from the city of Gomorrah. To do that, we're going to use a machine called an X-ray fluorescent spectrometer. What is an X-ray fluorescent spectrometer, you might ask? And why are we using one? Well, the first thing maybe to discover about an X-ray fluorescent spectrometer is that it comes in at a price of around about £130,000 plus VAT. You also need lots of other things to prepare the samples, so about another 20 grand's worth of machinery is going to be used. About 150 grand altogether is the cost of the kit that we're going to use to analyse these substances. An X-ray fluorescence spectrometer is a kind of a combination of a supercharged X-ray machine combined with a highly intelligent set of electron microscopes. The X-ray fluorescence spectrometer shows us the ingredients of any substance and the proportions of those ingredients in any sample that we look at. Kind of works like that. Primary X-ray radiation is fired at a test sample and the back reflected radiation is picked up and we identify the elements. Here's a very basic diagram to try and explain how it works. Primary X-ray fluorescent rays are beamed at a sample. The reflected radiation is picked up by a detector, kind of the microscope. It sends the information to a spectrometer, which analyses it for elements, and we get a computer readout of what the sample contains. Another good reason for using an X-ray fluorescence spectrometer is that it's used to detect sulfur in automobile fuels, so it's actually the perfect tool for the job. And because we're only going to analyse one substance, it should be a very simple test for the machine. So first of all, we start preparing samples for analysis. We take our laboratory refined sulfur, which we know the value of, and we mix it with a substance called lithium carbonate. We do this for two reasons. We get a very even sample because the lithium carbonate is a binding agent, so there's no lumps and bumps in the sample that the machine's going to look at. We also do this so that we can make samples in 3 different strengths. If we just look at a pure sample, the machine will say, yep, that's a pure sample. So if we split it up into 30%, 60% and pure, then we know that we've got a fairly accurate average to work on. By the way, preparing the samples takes about 2 hours, and if you'd like to know a little bit more of that, I suggest you watch the film. So our samples are ready